inaugural session of the 6-day virtual faculty development program on optimization techniques and machine learning for engineering applications, scheduled from 9 to 14th March 2026. I would like to express my sincere gratitude to the management, principal, head, Department of Mechanical Engineering for their continuous encouragement and support in organizing such academic initiatives. This FTP has been organized with the objective of enhancing the knowledge and research capabilities of faculty members and researchers in the emerging areas of optimization, techniques, and machine learning for engineering applications. It's our it's my privilege to have with us today Dr. M. Selvam, Associate Professor, Head, Department of Mechanical Engineering, who will preside over this inaugural session. We are also delighted to welcome our distinguished speaker for today's technical session, Dr. G. Anil Kumar, Assistant Professor, Department of Mechanical Engineering, Lendi Institute of Engineering and Technology, Andhra Pradesh. We warmly welcome all the faculty members, participants who have joined in this FDP program from various institutions. The rapid growth of artificial intelligence, optimization algorithms, and machine learning techniques has significantly influenced modern engineering research and industrial applications. This 6-day FDP aims to provide a comprehensive platform for participants to gain insights into optimization techniques in engineering systems, applications of machine learning in engineering problems, AI-driven solutions for sustainability and energy efficiency, emerging research opportunities in intelligent engineering systems. We sincerely hope that this program will serve as a valuable platform for knowledge sharing and academic collaboration. Now I request Dr. M. Selvam, Head, Department of Mechanical Engineering, to deliver the inaugural address and share his valuable word with the participants.
Yes, sir. So, good afternoon to everyone. I am Dr. M. Selvam, Associate Professor and Head, Department of Mechanical Engineering, and it gives me immense pleasure to welcome you all to the inaugural sessions of the online 6-day faculty development program on optimization techniques and machine learning for engineering applications. On behalf of Department of Mechanical Engineering, I warmly welcome all the distinguished speakers, faculty members, researchers, and participants who have joined us from various institutions across the country. This faculty development program is organized by the Department of Mechanical Engineering, Veltech Multitech, Dr. Rangarajan, Dr. Savandala Engineering College, and it will be conducted from 9th March 2026 to 14th March 2026. At the outset, I would like to express my sincere gratitude to our esteemed management for their continuous encouragement and strong support in promoting academic excellence, research, and faculty development activities in our institution. I would also like to extend my respectful greetings to our Honorable Principal for the constant guidance and motivations provided to the department in organizing academic programs that enrich the knowledge and professional skills of the faculty members and researchers. In today's rapidly evolving technological world, optimization techniques and machine learning have become essential tools in engineering research and industrial applications. These technologies help in solving complex engineering problems, improving efficiency, and enabling intelligent decision making across various domains. The faculty development program aims to provide a platform for knowledge sharing, research discussions, and exposure to emerging trends in optimizations and machine learning applications in engineering. We are privileged to have a distinguished panel of eminent academics and experts from reputed institutions who will share their valuable knowledge and research experiences during this program. We are honored to have the following distinguished speakers: Dr. G. Anil Kumar, Assistant Professor, Department of Mechanical Engineering, LAET, Andhra Pradesh, who will deliver a sessions on AI-driven optimization for circular economy and energy efficiency. The second one, Dr. M. Uday Kumar, Professor and Joint Director, Department of Mechanical Engineering, Amrita University, Kollam, who will present a sessions on machine learning predictions of surface roughness in sustainable machinery. Dr. Surendran, Professor, Department of Computer Science and Engineering, NIT Puducherry, Karaikal, who will speak on AI tools for education and research. Dr. K. Balamurugan, Associate Professor, Department of Mechanical Engineering, SRM University, Madurai, who will deliver a sessions on optimizations driven machine learning from classical theory to intelligent autonomous systems. Dr. S. Tirumali Kumaran, Professor, Department of Mechanical Engineering, PhD Technology, Coimbatore, who will present a sessions on optimizing hybrid technologies in machining. Dr. K. Upayaraj, Associate Professor, Department of Mechanical Engineering, KIT, Coimbatore, who will speak on integrating circularity metrics with environmental assessment. Dr. A. Santosh Kumar, Assistant Professor, Department of Mechanical Engineering, SRM Institute of Science and Technology, Ramapuram, who will present a sessions on machine learning based parametric optimizations for clean and efficient low temperature combustions in diesel engines. Dr. R. Naveen Raj, Assistant Professor of Department of Mechanical Engineering, NIT Puducherry, Karaikal, who will deliver a talk on probability optimization techniques with scarce data. Dr. S. Badrinath, Head and Associate Professor, Department of Mechanical Engineering, Kalaslingam Academy of Research and Education, Krishnan Koil, who will present a sessions optimized and decision making techniques in Industry 4.0. Dr. J. Anand, Professor, Department of Mechanical Engineering, Sona College of Technology, who will present delivery sessions on distributed rooftop solar system, a comprehensive technical overview. Dr. A. Valasudhagar, Assistant Professor, Department of Mechanical Engineering, Sona College of Technology, who will speak on a hybrid ML-based cutting temperature predictions in hot milling under sustainable lubrications. Dr. Wakia Anthony Amalan, Associate Professor, Department of Mechanical Engineering, PSN CET, Tirunelveli, who will deliver a sessions on material characterizations through machine learning techniques. With such excellent lineup of speakers, I am confident that with this FDB will provide valuable insights and contribute significantly to the academic and research development of all participants. Once again, I warmly welcome all our resource persons, faculty members and participants, and I wish this faculty development program a grand success and a fruitful learning experience for everyone. Thank you. Thank you, sir, for giving this opportunity. Thank you.
Thank you, sir, for your motivating and insightful inaugural address. It's now my privilege to introduce today's distinguished resource person, Dr. G. Anil Kumar. So we are honored to have with us eminent academician and researcher Dr. G. Anil Kumar, who will serve as a resource person for this program, FDP program. Dr. Anil Kumar completed his PhD from NIT Puducherry and has contributed significantly to research in areas such as e-waste management, assembly automation, design for manufacture and assembly, and circular economy. He has published several research papers in reputed SCI and Scopus indexed journals and actively contributes to the academic community as a reviewer for various international journals. Dr. Anil Kumar, G. Anil Kumar has also been involved in curriculum development, research supervision and academic activities related to the advanced manufacturing and engineering system. His research contributions and academic experience will undoubtedly provide valuable insights and inspiration to all participants attending this FTP. We are honored to have him with us today to deliver a session on the topic AI-driven optimization for circular economy and energy efficiency. Now I invite Dr. G. Anil Kumar to deliver the technical session. Sir, the session is yours. Sir, you can start the
Okay.
technical session, sir.
Okay. Thank you, Shivkumar. Am I audible for you?
Yeah, yes, sir. You are audible
Yeah.
to
Yeah.
everyone.
Thank you, Shiv. Yeah. Thank you for the confirmation. So just now I will switch on to the slides. So please let me know whether that is visible or not.
Yes, sir. Yes, sir. Yes, sir. Your presentation is visible to everyone, all the participants.
Yes. I hope everyone is visible with my presentation and audible with my words also.
Yes, sir. Yes, both visually and what it's
Yeah.
audible
Thank you.
also, sir. Yes, sir.
Thank you for the confirmation, Shivkumar. First of all, I want to thank this well-tech interviewer engineering college for giving this opportunity and the coordinators and wishing the coordinators the grand success about this event. Um, and I want to extend my thanks to every one of you here who are participating here and for the different institutes. So as introduced as Dr. Shiv Kumar already introduced me, I am Dr. G. Anil Kumar from Indian Institute of Engineering Technology, Andhra Pradesh. So today I'm going to deliver my expertise over the topic AI-driven optimization for circular economy and energy efficiency. I hope first of all, just I want to clear everyone is known about the circular economy. So in the presumed assumption, I was going to I'm assuming that everybody known about circular economy. So if anyone not known, just I'm giving a at a glance idea about the circular economy. Circular economy is nothing but compared to the traditional linear economy, take, make, use, and dispose. The circular economy try to convert the trash into treasure. That means after the product's end of life, whatever the product actually we are using, that means whether it can be a cell phone, or it can be a pen, or it can be a home appliance, whatever the product actually we use to manufacture, after its end of life, the materials in the product can have a value and it can be used in the manufacturing of the future products. So in order to enrich the in order to encapture the product value and try to preserve the value in the future manufacturing, the circular economy targets. So in that circular economy, what is the role of AI and why the optimization with the AI is required? I am going to explain in the further sessions, further slides. So these are all the countries I have planned. The first thing I want to give a brief introduction about what is linear economy and the circular economy. Why the linear economy is failing as of now, and what is the need of circular economy and the sustainability goals. So what are the 17 goals given by the UNO and how many goals we can cover in our designs as a mechanical engineer? How many goals actually we can cover? So that we are going to expand this session itself, and later multi-objective optimization. So what are the objectives are essential to consider when you are trying to deliver a product on time with a less cost by ensuring the product value, and the thing is we want to satisfy the customer needs and the manufacturer's goals of improving the productivity. So what are the different kinds of objectives are existing? So and then conventional optimization methods. As so far we are using these kind of optimization methods even today, even up to today also. Today we are just using these conventional optimization methods, even though those are working well. But why we have to shift for this come from the conventional to AI-driven optimization? So later that multi-criteria decision-making methods. What are the other methods are existed compared to conventional optimization methods? So later the significance of AI techniques, and at a glance over the different AI techniques which are used formally using in the circular economy. Later the later genetic algorithm. So although different kinds of AI techniques are existing, but we cannot cover all the AI techniques and their working with the circular economy is not possible in one session. So that's why just I'm restricting my lecture about to the genetic algorithm. So what are the parameters we consider? So the approach what I'm trying to teach today is definitely it will be it can be adaptable to any AI method also. So while you are using the any AI technique, what parameters you have to consider for training your model, and later on, I'm giving one case study because teaching everything in AI it is not it's not good. So how can we apply the genetic algorithm in the circular economy point of view for a case study? So the case study what I pick that is everybody knows their product and everyone can take the product into their pockets also. So while I'm explaining that case study, everyone can interrelate what is happening in our life. So later onwards, different challenges and future directions in this aspect. AI-driven optimization for the circular economy. What are the challenges that existed? Yeah, simply some actually whatever the advanced methods we are going to adopt, that is not a final solution for every problem we are seeing as of now. Of course, still many challenges are existed. So while addressing these challenges, whatever researchers will come into the picture. So in which way the research can be extended, and the future PhDs how can we extract from the this kind of research gaps. So later onwards, conclusion of this session. So these are the 10 contents I planned. So first of all, I want to thank every one of here who are the faculty from different institutes. They make their time to attend this session. So hopefully, if you have any queries during the presentation, please keep the query aside and you please ask me at the question answer session, which I will give you in the last 5 to 10 minutes. Even though the time extended, no issues, but keep your questions aside. So if you think definitely that question may if you cannot ask this question as of now, okay, maybe it will obstruct your flow. Suppose if you think that question is very much important to resolve, so then you please type it in the chat box. So the coordinator will inform me about that person. So this is my instruction regarding the session. So now coming to the presentation, linear economy. So here one can see the presentation itself. Take, make, dispose. So one more thing this we didn't cover here: the take, make, use, and dispose. Take and make are in the manufacturer point of view. Use and dispose will come into the customer point of view. So what is this take and make? So taking of the raw material from the ore. So whatever the smelting process, cleaning process, processing, and converting that into the billets. For example, if you take a steel, whatever the grills actually made in the next to me, what is the beside to me, what are the grills are made. So this may be from the cast iron. This cast iron is initially it is existed in the ores. That ore from that ore the mineral is taken and then it is processed. The smelting process is there. Thereafter in the some in steel plants some processing is there. The cleaning and then the converting into some wires or the tubes. So which is the favorable material. In the favorable form we can make it, and later we used to extend our technique. The take means taking of the raw material. Making means applying our own manufacturing method to get the desired product. So the take make is from the manufacturer point of view. So taking of the raw material and applying the manufacturing method, and after assembly, IBP is required, and after inspection, they can directly launch their product into the market. So later the supply chain management will come into the picture. They used to advertise their product and different ways, and then they will attract the customers. The customer will buy the product and then he use it after its end of life. Every product should go for the end of life session. So end of life phase, actually every product should go. So if you divide the product life cycle, divide the product life cycle, it having the different stages. The first is the development stage, second stage is the manufacturing stage, third one is the use stage, fourth one is the end of life stage. So after this end of life, the customer they never bother about the product. He directly dispose it into the environment. He can directly discard it into the environment. Suppose if it may have some scrap value, that scrap value and the further processing customer won't care about that. Even the manufacturer also won't care about that product. So this is the practice happened so far in the industries from the industrial revolution. So one can observe in this the text what I have given in the linear path take, make, use, and then dispose. From the industrial revolution one, two, and the third industrial revolution also. These are three industrial revolutions we have seen the linear economy at where the take, make, use, and dispose is happening. The first assumption with this linear economy is that resources are infinite, but it is not true actually. So when the industrial revolution one two is happened at that time, maybe the resources are plenty, and because the customers are very few. But in these days, the customer changes are different, and the customer priorities are the different, and the global population increases, and at the same time the lifestyle also changes. So these are all things will come into the picture for the future manufacturing. So then the competition also increases. Nowadays, the war is going for the materials also. So now we understand the resources are not infinite; they are unsustainable, and discarding these kind of products into the environment can create a lots of waste and pollution. So after suppose if you dispose these products into end of life, definitely it will create a environmental damage that everyone knows. But what had happened in terms of future manufacturing, so if you see the carbon footprint is nothing but the how much of carbon dioxide emissions is released into the environment for the production of 1 kg of material. I am just displaying these things only in the manufacturing, sorry, in the material extraction stage only. After that, the manufacturing stage it is different. There may be some possibility in the manufacturing stage, and in the use stage also some kind of carbon dioxide emissions will come. So one can see the footprint. See here, one can see the footprint. So the most of the contributions are from the industry side and the electricity and heat. Industry is the major contributor for the carbon dioxide emission. Here it is 20%, and electricity and heat. These are about the 18%. These are all the indirect parameters. So in the domestic purpose, of course, we use the electricity. But the thing is, industries consume more about the electricity. So in this way, we can understand nearly 38% it is contributing for the carbon dioxide emission into the environment. So everyone knows that how many tons of carbon dioxide is required to rise 1 degree centigrade of the Earth's temperature. So everybody knows about that. So that's why I'm not going in detail about the carbon footprint. So here one can see the major contributor is the 20%, the industry is 38%, and fuel production and transmission, which is also indirectly related to the industry, that is at the 4%. So nearly one can see 50% of contribution is from the manufacturer side. So the 21st century, our the first motto is to eradicate this kind of carbon footprint. So how can we how can we eliminate, or at least we can reduce this kind of carbon dioxide emissions into the environment? So scientists made a rigorous investigations. They have observed that the material extraction phase is a major contributor, because one can see the metals, aluminum is the primary material. The primary material, of course, the recycled material also by having some footprint, but the primary material of aluminum it can produce 11 to 17 kgs of carbon dioxide into the environment for production of 1 kg of aluminum. Whereas for the copper, the steel itself actually 2.5 kgs of carbon dioxide 2.5 kgs of carbon dioxide per produced per 1 kg of steel. So one can imagine the steel grills, etc., whatever using the other two wheelers or the four wheelers, or whatever the steel products as of now we are using, that is the expense of the environmental health in terms of the carbon dioxide. For example, you can see the different kinds of materials family what I have displayed here: metals, polymers, composites, the construction, and the other. So major contributor is the our mechanical engineering sector only contributed more, as the mechanical engineers can run the world, at the same time we can ruin the world without the decisions also. So in which way we can save the environment? So we can see in the next slides. So later we can see the how what the Rajadapno have seen the how much of carbon dioxide is emitted into the environment due to for the virgin material production. So if you go on production and you follow the linear economy principles only, take, make, use, and dispose. As of now, you can see how many products manufacturers or what are the product manufacturers collecting their products under the extended producer responsibility. Have you ever about the extended producer responsibility? It is fine. Else you just pay attention to my words itself. Extension producer responsibility is a policy framed by the Indian government. Not only Indian government, but globally also it is the policy is framed. That means the manufacturer has to take the responsibility of collecting their products after its end of life, and they have to process the product after its end of life for the future manufacturing. They are given with the incentives. They are given with the incentives to suppose if they collected their product, and they are given with the incentive also. Later onwards, one minute. Sorry for the disturbance. Yeah, sorry for the distance. Yes. So you can see how many materials are here. I am representing the periodic table. This is the one research made by the Chemistry Innovation Resource Support. So here one can see the limited availability of the materials in the terms of future risk of supply. So one can see in the yellow color highlighted things. So one can see the products actually materials have highlighted: lithium, magnesium, scandium, vanadium, chromium, manganese, cobalt, nickel, strontium, yttrium, zirconium, niobium, molybdenum, so tungsten. So all the materials, whatever the materials are listed here, are highlighted here. These are the limited availability and future risk of supply is existing. One can understand why the lithium-ion batteries are very much costly in these days, and the recycling of lithium is very much important for the future manufacturing. Uh, as we are assuming that, as we are assuming that the future of the automobile is nothing but the electric vehicles. So for the electrical vehicles, we need the lithium-ion batteries. But so this is also in the future risk of availability. So later onwards, we can see the which are the highlighted in the brown color. So rubium, rhodium, tantalum, platinum, uranium. These are the materials. These are the materials can can be in the endangered mode and right from the increased use. Okay, so these are the materials mostly used in the mobile phones and the screens of the laptops or the TVs and such kind of thing. So in order to their extensive properties, these materials are extensively used for these outstanding properties. But the failing of the failure in closing this material supply chain. So these are also went in the endangered session. So later onwards, we can see the next, which are highlighted in the red color. These are the materials existing the severe threat: hafnium, zinc, gallium, germanium, arsenic, and helium. Yes, and one can see the highlight of AZ, which is nothing but the Argentina silver. So nowadays one can who are following the updates of the business, they can understand why the silver prices are in the hike, because the solar panels, electrical vehicles, everything required for the it required the silver, and this silver is in the serious state in the next 100 years. So that's why every country trying to increase their silver reserve to capture the demand of the future. So that's why silver prices are increasing as in these days. Yeah. So these are the materials are endangered, and the scarcity of the materials in the future manufacturing, in the further future manufacturing. So now the manufacturer engineer or the design engineer, he has to think this thing in his mind. So in the earlier, just in the industrial revolution one and two and one and three also, the industrial engineers are the design engineers. They concentrated over the delivery of the products on time within the less cost. Even the customer also wants the product with the less cost. The manufacturer wants the profit, and customer also wants to get the product with the less cost. So here in the industrial revolution 1, 2, and 3, cost is the main parameter, and delivery of the product on time and launch of the product at the right time in the market. Because of the competition, if the product is going to launch within the short time and capturing the demand is the objective of a manufacturer or an industry engineer. Time and cost are the first primary objectives in the up to industry 1 and industrial revolution 1, 2, and 3. Whereas for industry 4.0, we have to consider the material demands also into our mind. So apart from the material, what are the things actually just we have to consider in our design? So nearly these are the 17 goals are framed by the United Nations organization UNO. These are the global 17 goals they have given for the sustainable development of the society. Of course, these 17 goals are not related to our mechanical engineering perspective, but most of the goals are either directly or indirectly are affecting our design. For example, if you see goal number 1, no poverty, zero hunger, and gender equality, goal number 5. Goal number 10, reduce inequalities, and goal number 16, peace and justice, strong institutions, and to 17, partnerships for the goals. These goals are not directly aligned to the mechanical engineering or the circular economy point of view, but these are definitely related to the our circular economy models, because no poverty, we have to create an employment for the future mankind. Whereas the robotics are coming into the picture, and humans, the jobs are getting laid off. How can we ensure the no poverty and zero hunger? In this way, we have to think our design where we have to satisfy the sustainability goals and the manufacturing goals also. So for this, we have already addressed what are the manufacturing goals, the time and cost. So these are the manufacturing goals, and customer, the user experience, and the low cost that is his goal. Whereas the global goals are these are 17 goals. So earlier the time and cost is our objective. So whatever the conventional optimization methods are existed, we can execute on that. But as of now, nearly the 17 goals you have seen here. So now this is not a single objective problem or a two-way objective problem. Definitely it is a multi-objective optimization problem which cannot be executed with the conventional optimization methods. So just I will explain what is the circular economy. So far what are the drawbacks that existed in the linear economy that can be covered in the circular economy. So here you can see different where are the different phases are existed in the circular economy, and how and in which way the manufacturer or the industrial engineer or the design engineer has to work on this. In the raw material space, what are the materials are recycled? What are the materials are recycled and collected from after its recycling? These materials should be used. We should ensure their functionality and their properties to meet with our product requirements. In the design stage, we should give the optimized design, and the production stage also we should reduce the resources consumption. In the retail point of view, that means in the who are all in the supply chain management, who are the stakeholder it existed. So in that retail phase, we should give the product with the less cost and with the good aesthetic experience, and we should ensure that user experience also good, and the consumption. That means while it's using, the user should give a good feedback. I should feel happy after buying the product, because most of the manufacturers now they build their brands. So they are not only selling their product, they are selling their reputation also. One can remember while launching the iPhone 15, I think so, iPhone 15 or 13, when some flaw actually came in that model. But the entire iPhone company CEO he used to come into the picture, and he used to say the apology, and they're collecting all the products wherever the issue came. And the same thing didn't do by the OnePlus, so that made the loss of reputation in the market by the OnePlus itself. So now we are selling so one should keep in mind, we are not only selling the product, we are selling the brand and loyalty to the customer. So in the use phase, we should understand what are the things can satisfy by the customer, and next the reuse and repair, and then the collection, and then the recycling. So in all these aspects we have to consider. Suppose we are making a product, we are designing a product. So nowadays this is the AI word. We can say this is the AI word. So in this time, how can we can increase the service to the customer in this competitive field. Even just there's some startups coming, new entrepreneurs are coming, new brands are coming. So in this competitive world, how can we obtain the trust of the customer? So in how many ways we can keep our customer that the manufacturers are looking as of now. So next slide. So these are the different optimization techniques. I'm giving at a glance. I'm not going detail about these techniques. So the conventional techniques and the non-conventional techniques. So the conventional techniques, of course, this one can easily understand why this conventional technique, why you should call as a conventional technique. Okay, so the random search method, univariate method, and pattern search, gradient search, all the methods are not applicable as of now. So these are not applicable as of now because we are dealing with the multiple goals and which cannot be achieved with the conventional methods. Whereas in the non-conventional technique also, if you see the deterministic technique methods like linear programming, what I listed here, LP, MILP, QP, BIP, so linear programming, mixed linear programming, and then binary set programming, and then quadratic programming. So all the deterministic methods also which we introduce in our UG courses, those methods are out of date as of now to solve the multi-objective problem. So here we can see the hybrid methods and the meta-heuristic methods. So these are the techniques which we are going to use to solve the multi-objective optimization problem in the circular economy perspective. So these are the some methods and these are the most majorly applied methods. So one can see the meta-heuristic method, genetic algorithm, particle swarm optimization, and artificial deep colony method. Okay, so some different techniques are existed. Other than this also existed, but majority, most of the researchers prefer these kind of techniques to solve the multi-objective optimization problem. Whereas some researchers, out of their curiosity, they are producing a hybrid methods also. They're taking some good qualities in the GA and some good qualities in the PSO, and they're training the models and giving the data, and they're showing it will give the good performance compared to that models. So all these things are working out. So this way actually research is going on, but discussing all the hybridization of methods is not possible in this 1 hour. So I will try to give the limited information that information can be valuable for your case studies also. So these are the optimization, the limitations in the conventional optimization techniques. First thing is the high computational complexity. That means when you are trying to suppose even though just we have enough sources like Meta, Gemini, Notebook LM, Chat GPT, they can give out code. So if you demonstrate your problem, they will definitely they will give us a code. Whether it will work or not, that we have to test it. But so while when you are selecting a
Anil sir, your voice is not audible, sir. Dr. Anil Kumar. Dear participants, there is some technical issue, so he will come back in a few minutes. Stay tuned. Thank you very much for rejoining. Yes, please continue, sir.
Yes. Yeah, yeah, okay. So sorry for the interruption.
No issues.
Okay, fine. Yes. So when you are selecting any AI method, first we have to understand where our conventional optimization technique is lagging. So the first thing first, if you want, if whatever the conventional, whatever the method actually you know whether they're deterministic or non-deterministic. Suppose if you go for the
Anil,
deterministic,
there is
easy
Anil Kumar.
pro.
Sorry for the
Tell me, tell
interruption.
me,
Could you please
tell me.
move that block, sir? Yes.
Which block?
Yes. That's it, sir.
Yeah. Okay.
Yes. Yeah. Good, sir. Yes.
It's okay. Yeah.
It's comfortable, sir.
Okay, fine. Yeah. So first thing, just you have to understand where there is the whether it is computational complexity exists or not. For example, if more number of variables in constants are existed, then you have to switch on further a method. Otherwise, just you can stick it for the conventional optimization, like method LP, MALP, like that. So and later, difficulty handling uncertainty. So the traditional models like LP or MILP or BP or quadratic programming, all these methods, the traditional model, first they assume the precise data. Okay, the precise data they used to assume, because okay, this assumption also valid when it is in the product development phase, because we are assuming that everything on time, and whatever the raw material we have taken, that is at the good quality, and whatever the uncertainty also exists, that we can address. And so while in the assembling phase also, one can understand in the assembling phase also, suppose if you want to put a shaft in a hole, the shaft diameter is fixed, where the hole also, it is also fixed. So we can ensure that the fitting of the shaft in that hole in the assembling phase. Whereas for the when you're trying to recycle or the reuse or the remanufacture or the repair, we cannot know whether this shaft will go into the hole in the as actually it went into the as like it went into the went in the development phase. Like what I'm trying to convey is, we cannot ensure the structure of the product, what we have made in the structure of the product, like whether in the development stage the product is in the good condition. Whereas after its end of life, we cannot know the product value. At that time, we cannot think about the data is precise and the realistic also. So the difficulty handling and uncertainty, and later that limited capability for the dynamic systems. Latest, most of the objective methods are optimization methods are single objective focus in many models. Later, that complex mathematical formulation. So these are the different limitations that exist in the conventional optimization techniques. So these are the goals in future manufacturing. So the significance of AI in the future manufacturing is, first thing, it can give the improved efficiency and can ensure the safety and compliance. Competitive advantage also we can take, because whatever the data we have given, it will solve within the less than seconds or less than minute itself. So competitive advantage we can take, and data-driven decision making. So because just whatever the data we have given, they never think about that what the data is existed. That is also one of the drawback in the AI also. But whatever the data we are giving, that based on that data, it can give us the decision making also. You the customization and the personalization. For example, just if I want to make a washing machine, so far we are going in the linear business model, linear economic business model. So we are assuming that water is having this kind of TDS. For example, if you are delivering a two wheeler, so they will give us a mileage with in that mileage also in the case. So for example, if you take any bike, two wheeler, it will give 65 kilo kmpl, and that 65 kmpl on the top also they have given asterisk like a star marker. That means conditions used to apply. Even suppose if I deliver suppose if I design a washing machine, in that washing machine also they are assuming the TDS of the water. So based on that, they are giving the guarantee of the product. So nowadays you cannot see the guarantee of the product. Most of the products are coming with the warranty only, because we cannot suspect or we cannot understand what are the actual conditions and the practical conditions. So now in the customization personalization, for example, is I am the customer, and as so far I'm using a Whirlpool or LG different kind of washing machine. I have some faith over the LG company, so I used to order a washing machine. So then the client can directly interact with the manufacturer, and he can give his requirements, like my water is having TDS this much, and I am from a rural area, and maybe I am from the urban area. Here the groundwater resources are very low, and I am trying to make my electricity bill into this much only. So even I don't have more number of clocks. So I mostly I used to prefer this class only. That means the features can be optimized. In this way, the product can be delivered on time. At the same time, it can meet the customer requirements also. So in this way, product enhanced quality come, and supply chain optimization also will come, because the whatever the feedback is given to the stakeholder, that is taken by the manufacturer, and they were upgrading in their product. So far actually this one of the upgrades actually coming. The customer feedback is given to any stakeholder, like a home appliances person. He used to take, and he used to send that data to the manufacturer. Based on that feedback, they used to upgrade their designs. But now, here the customer can directly share his feedback to the manufacturer. However, he can implement if it is a valid. And later the cost reduction also. Suppose suppose if you're giving a 10 features, which is the customer don't want to use out of 10, they don't want to use the 7, but still the 3 features he is using excessively. So in that way, we can limit our features, and we can reduce the cost, and we can ensure the customer satisfaction also. So these are the different goals in the future manufacturing and significance of AI in the manufacturing. So now I am bringing out a case study. So this is the case study everyone can see, which is this is the product which can fit in everyone's pocket. So these are the different parts existed in a ballpoint pen. So one can see upper barrel tip, latch hole, upper clip, lower clip, body and lower barrel slot, upper barrel grip, and the funnel, ballpoint and ballpoint tip, ink chamber, spring coil, plunger, clicker shaft. So the different parts are existed within a pen. Suppose if you want to make a product, if you want to make a product in terms of circular economy, not a linear economy. So far, everyone actually just we are using pen as a linear economy model only. This is the way actually just I used to pick this product. So one cannot think about the circular economy, because the manufacturer can ensure he used to deliver his pen. So how many pens are actually going to sell by a stakeholder? That means if the number of pens are going to sell by used by the customers. Suppose if 100 products he is used to give an order for the stakeholder. If that 100 pens sold out within some limited within the less period, so that product is success. That is what we are assuming in the linear economy. Suppose if you want to make this product in the circular economy, what things we have to consider? Just now I'm trying to explain. So first thing is we have to make the life cycle analysis. In the product life cycle, what I have shared in the beginning of this session: development phase, manufacturing phase, and distribution phase, use phase, and end of life phase. So after this, what are the materials are collected in the recycle, and they are using in the future manufacturing. So these are the different stages actually we have to consider. Sorry. So in the first stage, we have to give in the life cycle analysis goal and scope definition. That means goal, whether you want to restrict your study only about the use phase or development phase, or the manufacturing phase. You one phase you can take, and you can minimize the life cycle. You can minimize the environmental resource consumption in that particular phase itself. That will also valid. At the same time, what are the influence of that reduction of natural resource consumption in that phase over the other phase? For example, in the development phase, sorry, in the manufacturing phase, you might reduce the carbon dioxide emissions. The CO2 footprint by 10 to 20 percentage. Maybe it will affect 90 percentage reduction in the carbon footprint in the next days. Now the case of the pen, maybe if you take a different product like fans, washing machines, TVs, mobile phones, like that. So in which way and in which area or in which phase you are trying to work out, that is you have to define the goal, and the scope you have to mention. At the same time, in the second stage, life cycle inventory. That means what of the previous data is existed. What of the previous data is existed, that we have to ensure in the stage 2. But what type of data you are taking, that is very much important. For example, if I am trying to design a pen. I was taken a this kind of pen, which I can operate with a spring. Suppose if I take another pen which can open with a cap, that is not valid. That means irrelevant data will come. Whereas for the stage 3, the life cycle impact assessment. So the stage 2 is very much crucial and stage 1 is very much crucial. Stage 1 and stage 2, if you are clear, then stage 3 automatically it will come. So one should ensure that they have taken the right data and they have given the right goal. Then only stage 3 will come. After that interpretation, so it completely will lead to the industrial engineer. So who are going to take the decision, and later the manufacturer will understand. For example, just if I want to use a perfectly recycled material like a bamboo for my pen, maybe it will consume the more number of resources. If suppose if the cost of, for example, if I want to manufacture a pen with the cost of 5 rupees only, the manufacturer core is to wants the manufacturer pen by 5 rupees only. But if I, as an industrial engineer or a design engineer, I suggested for the best material, which can increase the product cost by 20 rupees, even though it is environmentally acceptable, but still we have to think whether the cost is acceptable or not. So the manufacturer will take a decision based on the interpretation. So these are the different steps in the life cycle analysis. So just I'm giving at a glance view about the environmental footprint of pen at the manufacturing stage. So we'll see first we have to understand what is the component, the bill of materials. Later which manufacturing process is used to obtain that component itself. Later carbon footprint, water footprint, and waste and other impacts. That means what are the waste coming from from that part at the manufacturing stage. These are the things we have to consider. So one can see 30 to 50 grams of carbon dioxide per pen, and zero point 0.1 to zero point 0.2 liters of cooling water only for production of the cap. So one can see how much of the environmental resources are consumed for the product which is fit into our pockets itself. Later, so these are the data is existed. Now our objective is to minimize the environmental footprint and get the product at the low cost. So what are the different methods are existed? So these are the different kinds of AI methods are existed. So we can see the nature-inspired intelligence like genetic algorithm, particle optimization, simulated annealing, and artificial intelligence systems, right? And we can see the ANN also, artificial neural networks, and machine learning systems, supervised learning, unsupervised learning, reinforcement learning, and the multi-agent systems. These are the different kinds of techniques we are having. But mostly of the mechanical engineers, most of the industrial engineers, design engineers, they used to prefer the machine learning methods and the nature-inspired intelligence. Nature-inspired, pardon, nature-inspired intelligence, because this is easy to understand and easy to adopt and easy to apply also. So I am taking the genetic algorithm. So genetic algorithm, these are the different steps that existed in the genetic algorithm. First thing is the initialization, later the fitness assignment, selection, reproduction, and the termination. So the initialization phase, first we have to create a random population. Later that we have to give the fitness assignment. In that fitness assignment, this is where this fitness assignment only, what is our role, that means what is the industrial engineer role will be seen. So what is your objective? For example, if your objective is to retain the sustainability score, for example, your objective is to improve the productivity, like in terms of using of the product. For example, if you want to reduce the time consumption in the manufacturing phase itself, okay, and reduce the reduction of the cost, increasing the product usability and reduction of the cost. So these are all the different objectives. So unless and until you fix your objectives, you cannot go for the next step. So the fitness assignment is very much important. So everything just you have to give the fitness score equals to 1 only. For example, you have a 6 objectives. Okay, whether you are giving a point, whether it is 1 by 6. Sorry, yeah, you can say that 10 by 6 itself. You can say you have maybe 4 objectives you have. So 1 by 4 you can use it like 0.25, 0.25, 0.25, 0.25, like equal priority. Suppose if you want to give that you can give. Otherwise, just you can give like zero point 0.6 for the one thing, and zero point 0.1, zero point 0.1, zero point 0.1 for the sorry, zero point 0.2, zero point 0.1, 0.1 for the other objectives. So the scores, whatever you are giving, that is your intention. Based on your objective, you can give it. So the fitness assignment. Later, the selection, reproduction, these things will done by the GA. So what the process actually will go on? This I will explain the next slides. So the first thing, see here, one code actually I have written. So we can see, we can run in the Python also. So first thing is we have to understand for the barrel. Okay, the barrel. I have taken two materials, recycled ABS and the polypropylene. So the two are the materials I have taken, and different scores I have assigned: 88, 0.08, and the 3. So these are the actually these are the 80 is meant for the grams. For example, I want to make a barrel. I want to make a barrel. It is made up of 80 grams. Suppose if I want to make a barrel, for the ABS it requires 80 grams, whereas for the polypropylene it will consume the 75 grams only. So then similarly in the next clip, refill, spring, ink. So these are the different components I have taken, and different parameters I have taken. So I have taken that part weight, and how much of time it will take, and how much of cost it will take, and what is the part number. So what is the priority of the part in the product. So these are the four parameters I have taken: barrel, clip, refill, spring, and the ink. So in the ink also I have given the oil ink and the gel ink. So these in this way I have given my priority, and the components I have addressed like this. And next, the fitness function testing, I have given that recyclability as my first objective. The score actually one can see the score is 0.4 for the recyclability, as it is a model for the circular economy. I give the recyclability as the highest. So recyclability and sustainability is there, and minus here, minus sign one can understand, 0.2 for minus, that means low cost and the low energy consumption. So in this way we can design our fitness function. So here I have taken the four objectives. One can take the n number of objectives. That is not an issue, but your data should be accurate. So later, how mechanism in the genetic algorithm will work means, so in the initial population, it will take population size as 10. That means 10 number of combinations it's going to generate. So in the 10 number of combination, which is the best one, it will select. So the population size, if you want to increase for the 100 combinations, it will check. But if you just, I will restrict it only for the 10 combinations. So that's why it will check in the 10 only. So the selection, that means it will pick it, and the crossover. One can see here the crossover. So the best things in the parent A and the best things in the parent B. So suppose for example, in one parent, like in one set of parts or one set of combination, maybe the barrel can be produced with the wood itself. Sorry, the bamboo itself, that is having the less cost. Whereas in the another combination, the refill, which is giving with the oil ink, that is now having with the less cost. So the best things from the parent that sequence, and that best in the second sequence, it can take and it can produce a offspring also. That means selecting the best thing from the different combinations it will take. That is the beauty of GA. So after that, the selection, and then crossover it will happen. So in the crossover, later actually just different kinds of mechanisms are existed, but mostly we can select the roller wheel mechanism only. So for the crossover, it is the best for the this kind of designs, and the mutation it will happen later onwards. The number of generations it will come. Initially, we have taken the 10 population size, but after that, the GA is observed that the combinations which can be altered, that is a 20. That means from we initially have given the 10, select the 10 combinations only, but in that actually you have taken the 10 and then produced the 20 combinations. That means here we can say that child 1, child 2. Okay, so the new population will come. So later onwards it will produce the best design among the combinations, whatever it is selected and whatever the parents it is selected, and finally it will give the best fitness point. So which is the best design, I will show in the next slide. So these are the different kinds of strategies or design strategies that existed. So as of now, we are working over the design for assembly and design for manufacturing, design for manufacturing assembly only. So most of the industry products or industry engineers are trying to work out over this DFA, DFM and DFMA only. But in future, definitely we have to think about the design for reliability and design for supply chain and design for sustainability. And design for cost also everyone know about this, because suppose if you take a if you take company like Apsara pencils or Apsara pencils, suppose if you take, so there is no alterations in the product will come. So we cannot go for the design for assembly or design for manufacturing assembly, but we have to think in which way the cost can be reduced in that product. That means the where the design changes cannot be happened, we can switch it for the design for cost. Whereas for the design for sustainability, one can understand what I am trying to speak out from the beginning of this session. So these are the environmental footprint of a pen with the cost analysis I have made. So if you see the conventional disposable pen, okay. So the conventional disposable pen, it is coming with a key advantage: cheap upfront, but high waste and recurring cost. That means the disposable pen cannot be recyclable, and every time this we have to search for the materials. So the life cycle cost is 50 to 100 rupees per 100. That means 10 pence per year will make the 50 to 100 rupees of money from our pockets. Whereas for the environment, it will take 200 grams of carbon dioxide, only one pen itself, and 1 liter of water also, and 7 grams of waste is going to enter into the environment. Whereas for suppose if you take the design for assembly, here somewhere like a carbon footprint is somewhat reduced, and water footprint also reduced for nearly half. Only half liter is consumed, because the beauty in design for assembly is fewer parts and easier to assembly and lower production cost. And design for manufacture and assembly, here one can see optimized material use and cheaper to make and assemble. So this is where the beauty of design things will come. For example, if you go for design for manufacturing, one can see how the life cycle cost is reduced. Here one can see only refill is replaced, circular economy, lowest cost, and the footprint. So this is the best way we can reduce the life cycle cost. But how much the customer acceptance is there, one cannot understand. Because if any pen is replaced with only with a refill, that is the best thing. But most of the customers, they used to dispose their pen, and they go for the new one. So the customer acceptance and the customer cooperation is very much important in the circular economy business model. Maybe in the future, different kinds of AI techniques are existed and they are coming. How to collect their products from the customer point of view. So these are the different types of pens. For example, if you take disposable pen, a refillable ballpoint pen, and eco pen, you can see eco pen bamboo or paper body plus refill. So this is the best one what we have produced from our research. So suppose if you want to make a product with a different in the different cities, okay, the resources will be different from the city to city. For example, just if you want to manufacture that pen in the Bangalore, the carbon footprint will be different. Whereas if you see in the Chennai, maybe just if you take 42 grams per pen, actually it is going to release. So this is the things actually just we can make in our designs, like different locations you can take, and the actual data from that location you can pick, and you have to think in the life cycle inventory. Later just you have to give it in the your AI mode. Otherwise it will give it whatever the AI, just whatever you give, it won't identify the data, but still it will produce the result. So direct adoptance of such kind of things will is not encourageable, and it will ruin our reputation also.
Dear partners, wait for a while. There is a technical error, so the speaker will join in a minute. Dear partners, wait for a while. So there is an internet connections with this speaker. So we will join in a minute. Thank you.
Yes, sorry for the frequent
No,
interruptions.
no issue, sir. Please continue, sir.
Yeah, okay. So, so one can think about that as product as a service model instead of the product. For example, just you are buying a service by from your brand. For example, just if I want to buy a washing machine, I want to buy the service by 8 years from the LG company. So I'm going to invest some money, give some money to that LG company. So thereby they used to ensure the service only within that 8 years period. For example, just whatever the product, whether it is a refurbished one or new one, that doesn't matter for me. The thing is, this they will deliver a product to my home, and I will use it. If any problems will come, so they will take back their products, and they will think about their repair and maintenance. But my service is guaranteed. So in future, definitely these things that the product service guaranteed models will come, and later that needs and extending product life and so tracking access to digital product passports like RFID tags are attached to our products. That means the life cycle, what are the things happening, the type of depreciation, are the product, you can say how much the material is degraded, and how the life is actually utilized, maybe due to frequent power failures or the water issues. Like I'm thinking about the washing machine now. I'm selling it the washing machine. What are the TDS of the water, and what is the electricity connections, in which way where actually they used to keep their product, and what kind of class they are used to put. So all this data will actually it will be covered. It will taken by the manufacturer, and he will process it, and he will give it to the customer according to the customer choice. So while they requires its energy, but its ability to optimize resource efficiency and unlock trillions in the economic value, that it was indispensable for achieving global sustainability targets and true resource resilience. So that's end of my presentation. Thank you everyone for your patience. So thank you everyone for your patience. Now the question session is open for the queries.
So, dear participants, do you have any doubt or questions? Please raise against Dr. Adrian Kumar. So he will clarify. He will answer your questions and your doubts. So, do you have any questions? Please post in the chat box. So I will bring it to the speaker knowledge, or else you directly ask to speaker. So he will clarify your doubts.
Participant can ask your question if you have, or if you can mail me. You please contact the coordinator for the mail. So he will share my details, and you can write to me at my email, and I will give you a reply whenever based on the previous and the importance of the question.
Yes. I think shall we conclude it, sir?
Yes, sir. It seems no questions so far. Yeah, please go ahead.
Yes. So thank you very much, Dr. G. Anil Kumar, for the highly informative and insightful session. Your valuable presentation on AI-driven optimization and its role in circular economy and energy efficiency has certainly provided new perspectives for all the participants. So thank you, sir. Thank you very much for giving the wonderful session. So with this, we come to the end of the day one, session one of the FTP. We look forward to the active participation of all the attendees in the upcoming sessions over the next 6 days. So thank you all for joining us. Have a wonderful and productive FTP ahead. Thank you, sir. Thank you, participants, and thank you, Dr. G. Anil Kumar.
Thank you very much, Dr. Shiv.
Thank you.
Thank you.
So, dear participants, you may leave the meeting.